Hello students, today we are going to discuss your worksheet number 35 for the date 23 September. Subject science. So in this worksheet, as you know, your chapter of motion is going on, and today we'll discuss about the position time relationship by the second equation of motion. So Gyan is asking her sister, what is second equation of motion? How can we derive it by graphical method? Jigyasa is saying when an object moves along a straight line with uniform acceleration, it covers a definite distance in a particular time interval. This distance can be calculated by second equation of motion, that is known as s is equal to ut plus half at square. So second equation of motion also represents the relationship between time and position, and this can be derived by velocity time graph of uniformly accelerating object. You have seen that graph also, that when an object is moving with a uniform acceleration, this is time and this is velocity. So on the basis of this graph we are going to find out this s is equal to ut plus half at square. So this is the graphical method of representing this equation. Here also we have taken initial velocity is not zero. Remember that in the last worksheet also this was there. You can see this is the position of A, that means the initial velocity is not zero. So what we are doing, we are drawing a perpendicular BC from the point B on the axis X. This one is we are drawing this perpendicular. We know that the distance traveled by the object is obtained by the area enclosed by OABC. So this area is the distance traveled by the object by this one. So the distance traveled by object is equal to area OABC. So S is equal to area of rectangle. We have divided this one. This is the area of rectangle OADC plus area of triangle ABD. So this comes out to be rectangular formula length into breadth, and triangular area formula is half breadth into height. So when we put the different symbols for these, OA is equal to U, OC is equal to AD minus OC is equal to AD, that means T, BD is equal to AT. From the last equation you can calculate, because A is equal to BD upon T, so BD is equal to AT. By putting these equation we get second equation of motion, that is s is equal to ut plus half at square. So u is initial, A is uniform acceleration, s is distance travel, and t is time. So this is a very simple one. Now let's see an example. A brake applied to a bus produces an acceleration of 6 meter per second square in the opposite direction to the motion. If the bus takes 2 seconds to stop after the application of brakes, calculate the distance covered by the bus in that time. So given acceleration is, because brakes are applied, minus 6 meter per second square, velocity is, final velocity is 0, initial we have to calculate, and v is equal to u plus at. So here final velocity is 0, u plus minus 6, a acceleration this one, and time is 2 seconds. So u comes out to be 12 meter per second, which we calculated in the last worksheet also. We putting the value in this formula, s is equal to ut plus half at square. Distance covered by the bus will be 12 meter. So this is how we can calculate the distance covered from this equation also. Next is the question answers. Check yourself. First question, write first and second equation of motion. First is v is equal to u plus at. Second is s is equal to ut plus half at square. Second question, derive second equation of motion from velocity time graph. You can all see from the worksheet, it is given in very simple language. Third question, and car accelerates uniformly by 1 meter per second, it's square. Okay, this star is actually square because it is acceleration. So calculate the distance covered by the car in that time. So initial velocity we are given 5 meter per second, final velocity 10 meter, time taken for change in velocity t 5 second. Therefore acceleration will be 10 minus 5 divided by 5 will be 5 meter upon 5, it will be comes out to be 1 meter, which is already given. Then using the relation s is equal to ut, you put the values 5 meter into 5 plus half 1 meter plus 5 square. So it comes out to be s is equal to 37.5 meters. So car covers 37.5 meter during the period its velocity changes from 5 to 10. So this is your answer. Hope you like this worksheet. Thanks for watching. Do subscribe the channel. Tell your friends to subscribe. Thanks.